Yo, yo, it's Josh. Today I want to go over systems of equations, and there are a lot of different ways to actually do these problems, but the most common ones are either elimination or substitution, and those are the ones I want to go over today. So the first one is probably the most simple. It's called substitution. This one is really good for, if they're just solving for x and y, or sometimes you'll see x1 and x2. And so it looks like there's only really three parts. So we see 3x, something with a y, and a 7, or another thing with an x, another thing with y, another thing with an 8. So, this is just an example. And so when we do systems of equations, we want to figure out when these two actually meet. So when these two functions. So if we put it on Desmos, so we go up here, we see that these are the two functions. We want to see that it meets at 3, 2. So the x value is at 3, and the y value is at 2. So if we do this mathematically, we can actually see that. So the first way is substitution. So we have our two equations right there. Usually what we want to do is we want to focus on one of them. So say let's focus on 3x minus y equals 7. First, what we usually try to do is we usually try to solve for y. So that means we can add y on both sides, and so 3x equals 7 plus y. We want y by itself, so we can subtract 7 on the other side. So now we have y equals 3x minus 7. And then that will be our y equation. But that's not a y value, we have an x in there. So what we can do is we can actually plug that into our other equation. So right here. So now we can have 2x plus, and we already solved for y, so we can just replace that. So 3x minus 7, and that should equal 8. So here's what we can do. Since they're added, we don't have to have the parentheses. So let's do that. So 2x plus 3x minus 7 equals 8. So now let's solve for x. So now we can move those x's together. Minus 7 equals 8. Add 7 on both sides, so 5x equals 7 plus 8. That's 15. Oh, in this case, x will equal 3. Because you divide by 5 on both sides. Alright, so now that we have the x equals 3 in that case, we can actually use any equation, any of the two equations that we were given, to actually solve for the y. Because since we have an equation, if we put an x value in, we should get a y value. So let's just use this equation, or actually no, let's use this one, because we already solved for that one. Oh, and that should be the same equation as this. So let's rewrite this one right here. So y equals 3x, and then minus 7. Oh, and we have an x value, x equals 3, so let's put that in. So y equals 3 times 3 minus 7. Oh, and that's just y equals 9 minus 7, so that means y equals 2. So these are our 2. So x equals 3, y equals 2. Let's see if we got it right. Oh, yep, we got it. So that's one way, and that's probably the more simpler way. But there's another one that's called elimination. This is probably the faster way how to do everything. And so what you usually do here, what we're taught is, it's a nice little trick. We put the equations on top of each other, add them together, and so this one would be 5x, negative y plus y, that's going to be 0, so plus 0, equals 15. Oh, and we're just back at our own place, 5x, what we had earlier. That means x equals 3, and then you plug it back in to one of the equations, and we'll get that. But the reason why this actually works is, let me show you. So let's focus on just the first equation. You see, this confused me when I was younger, first learning this, because I was like, I remember learning that the only thing we can do to one side is if we do it to the other side. So when we add the 7 and the 8, wait, shouldn't you add 8 on the other equation as well? But no, we're adding 2x plus y instead. So those are two different things. And so this is actually how it really works. Because you can't just add equations together. You have to add numbers. That too. So here's what we do. Well, let's put this in yellow. Well, how about we add a random 8 on both sides? That should be fine. As long as we do it to both sides, that's completely legal. It will still be equal. Because that should be the same. Well, we actually already said, that 8 equals 2x plus y. Right? That's okay. Okay. So how about right here, instead of saying 8, we can say 2x plus y. Oh, and then we still have that plus 3x minus y. That should equal that 7. Oh, and we could just leave the 8 to be by itself, because those two are still the same. These two are still the same. We already said that right here. Those are the exact same. Oh, so now we can add these together. And we can just simplify the left side. So 5x, because the x's. Y plus y minus y, that's plus 0. And that equals 7 plus 8, and that should be 15. Oh, and we're back here. 5x equals 15. And then we can continue solving here like we did at the last couple steps of substitution, right here. We found the x value. We can now find the y value. And that is actually how it works. Elimination. It's pretty simple, pretty easy. It's just kind of a hidden thing. That's how it works.